So today's lesson is on the effects of changing dimensions. So we were looking yesterday at what happens if two figures are similar. Every dimension in those figures are proportional to each other. Well, what happens if we only change one dimension, not all of them? So in other words, if I had a cube and I multiplied every dimension by 2, that makes that new cube similar. But what if I only change the height dimension of the cube by multiplying by 2 and not the length and the width of the base? Then I don't have a similar figure, but I can still determine the effects of that changing one dimension onto surface area and volume. It takes a little bit more work. So our concept is changing dimensions, or our topic. And these are notes for 11-12. So if the dimensions of a solid are multiplied by a scale factor of, we're just going to call it A. And so that's what we were working with yesterday. So it could be, I could be multiplying by 2, I could be multiplying by a third. That's going to be your scale factor A. Then the surface area, what do you think is going to be? How is it? What's the effect going to be on the surface area, based upon what we did yesterday? Not 2a squared, right? So because surface area is squared, that means that we're going to take that scale factor and square it. That's going to be the effect. So if I multiply one dimension by 2, what's 2 squared? 4. Then the surface area is going to be 4 times larger for that new figure. And manufacturers use this all the time to determine what affects changing their packaging. Or like if you buy a box of cereal that's, a small box versus a medium box, they're going to take that effect and see, well, how does that change surface area? How is that going to change my costs of packaging that cereal? So it's important that they are able to figure that out easily. So then what's your volume going to be? A cubed. So let's look at some simpler, make that just a little bigger. That's crooked, isn't it? There we go. All right, so if the dimensions of a figure are doubled, so keyword there, they're doubled, how many times larger will the surface area be? So if they're doubled, then they're telling you that A is equal to 4, or not 4, whoopsie poops. A is equal to what? That's A, to 2. And so if we're looking at surface area, won't I be looking at A squared? Right? So A squared is going to be 2 squared, which is what? 4. So that means, therefore, the surface area, I'm just going to abbreviate it, will be 4 times larger. The ... Are you talking about this right here? That's that ... Therefore. All right, so that's not too bad, right? Look at number 2. This time, that's it. That's all you had to do. Mm-hmm. If the dimensions of the figure are doubled, so A is 2, what's the effect on surface area? Square it, because surface area is squared. That means your surface area is going to be 4 times larger than the original one. We don't know what the original one was, so if the original surface area was 10 squared units, the new surface area is going to be 10 times 4, which is 40 squared units. Number 2 says the surface area of a figure is 62 centimeters squared. So they've given us surface area is this. If the dimensions are multiplied by 5, what will be the surface area of the new figure? So if the dimensions are multiplied by 5, isn't that A? So step 1, A, our scale factor, is going to be 5. Step 2, what are the effects of a scale factor of 5 going to be on our surface area? What are we going to do? Well, we're going to take and find a squared, right? So I'm going to take that 5 and I'm going to square it. Doesn't that equal 25?
Yep.
What that means is the new surface area is going to be 25 times bigger. Well, the current surface area is 62. So step 3, we're going to take the current surface area, which is 62 centimeters squared, and we're going to multiply it by our increase in dimensions. So take 62 and multiply it by 25. What do you get? So the new surface area will equal 1,550 centimeters squared. So example 2 was slightly different than example 1. We had to take it a step further. This time we knew what our original surface area was, and we know what we're multiplying the dimensions by. And mind you, on these examples, we're multiplying every dimension by that scale factor. So we are creating similar solids in these cases. When we get to the back, we're going to have non-similars. So we'll get to that in a minute. So then you look at number 3. They give you the surface area is 736 inches squared. If the dimensions are multiplied by 1/4, what will be the surface area of the new figure? So just because it's 1/4 doesn't mean anything. Don't let that bother you. Try to follow what we did in number 2. So talk in your table groups. So isn't your A equal to 1/4?
Yeah.
Right? And if we're talking about surface area, I need to find what A squared is going to be. So you're going to put that 1/4 in and square it. What do you get? What's 1 squared? 1. What's 4 squared? 16. So the new surface area is going to be 1/16 as big. So won't our new surface area get smaller? So anytime we have a fraction that's under 1, 1/2, 1/4, 1/3, 1/5, we're actually dividing by that. So look what happens in step 3. So step 3, we're going to take our original surface area, which is 736 inches squared, and we're essentially multiplying it by 1/16. Well, multiplying by 1/16 is the same as dividing by 16. So take your calculator and you're going to take 736 and divide by 16.
Yeah.
Well, because we don't multiply it because it's 1/16. So haven't we discussed where if you're multiplying by 1/2, we're really dividing by 2. If you're multiplying by 1/3, we're really dividing by 3. Right, Tristan?
Yeah.
Does that make sense? So we're all multiplying, but look what happens. Wouldn't we put this over 1? And wouldn't we see if 16 cancels into the 736? Isn't that division? Right? So what do we get when we actually divide 736 by 16?
46.
Yep. So our new surface area is equal to 46 inches squared. Look at number 4. Cone A is similar to cone B. So now we have similar figures. That means that all their dimensions are proportional to each other. So if cone A has a surface area of 1422 and cone B has a surface area of 158, how many times larger is cone A than cone B? So can't we do what we did yesterday and take A squared? Why am I doing A squared? Why am I doing A squared and B squared? Because it's surface area. So A squared is 1422, and b squared is 158. What are we going to do now? Well, let's find what a to b is. Won't that give us our scale factor? Right? So let's see if we can simplify 1422 over 158. So use that fraction button on your calculator. What'd you get? Okay, so this is step 1. Step 2, a to b. Oh, I'm sorry. That's not a to b. This gives you 9 to 1, doesn't it? If you put into your calculator this using your fraction button, those reduce to 9 to 1, don't they? That's still a squared to b squared. We haven't found a to b yet.
So it just has 9,
9 to 1. So if I'm going to make that into a fraction, I'm going to put it over 1, right? Now, what is a to b? What's the square root of 9? 3, and the square root of 1? 1. So my scale factor is 3, isn't it? Didn't we take the smaller and multiply it by 3 to get the bigger? Right? So how many times larger is cone A than cone B? Therefore, cone A is 3 times larger than, oh, that looks really good, huh? Than cone B. Except for the then. You okay with those? You have to, these are going to be harder today. You're going to have to practice them. Really look at your notes as you go through your homework. So then let's look at some volume examples. Those are all surface area. So look at number 5. If the dimensions of a figure are multiplied by 4, aren't they giving you A right here? So isn't A equal to 4? That's our scale factor. How many times larger will the volume be? So volume is A what? Volume is A cubed, right? So we're going to take our scale factor of 4 and we're going to cube it. What does that give us? What does that give us? 64. So therefore, the volume will be 64, let's make that legible, will be 64 times larger. So that's as simple as they come, and they start to get a little bit harder as we go along. So look at number 6. This time they give you the volume. The volume of a figure is 110.5 feet cubed. So the dimensions are doubled. What will be the volume of the new figure? So what do we do with that? Well, we have to figure out the dimensions are doubled, so you are correct, Tristan. A is equal to 2. Very good. So then, because it's volume, what's the effect of A being 2 going to be on volume? What do we do with that?
2 squared.
Is volume squared? Yeah, so we want A cubed. So we're going to put 2 in there. And what does that give us? 8. So that means our volume is going to get 8 times larger, right? So let's figure out that new volume. So step 3, our old volume is 110.5 feet cubed. And we're going to multiply that to our scale factor of 8, because we're going to make it bigger. So you just take 110.5 times 8. What do you get? So our new volume is equal to 884 feet cubed. What do you mean write it out? Well, I want to make it clear that that's our new volume versus our original. That's why I just do V sub new. only everybody would get to school on time. Number 7. Okay, so this time they give you volume again. What if the dimensions are multiplied by 2/3? What will be the volume of the new figure? So you go ahead and try that. That's just like the one that we did earlier, number 3, with the fraction. So don't let the fraction bother you. It's a combination of number 6 and number 3, right? As far as number 3 had a fraction, number 6 is just like what we did with number 6. So go through that process again. Katie, come on. Some of you are still asleep. So discuss your answers and your work within your group. So chit chat. Don't do it independently. You're supposed to be talking together. So what if you're doing it wrong? All right, so look up here. If we're going to multiply the dimensions by 2/3, isn't A equal to 2/3? Okay? And then if we want to see what the effect will be on volume, don't we have to cube that? So if you cube 2/3, you get 8/27. What are we going to do with the 8/27? Yes, we're going to take our original volume, which is 972 meters squared. We're going to put that over 1 because we're going to multiply it to our new scale factor for volume, 8/27. So in your calculator, it's just easy in your calculator just to take 972 and multiply by 8, hit equals, and then divide by 27.
Oh, I didn't do
What'd you do?
that. I just put 900 bottom of the bracket.
Well, 972 times 8 is 7776. Then divided by 27 is 288.
Oh, so I got that.
Yeah, so then our new volume, you got it right, you said?
Yeah.
Okay, is 288 meters squared.
I just did.
Oh, thank you, cubed. George is awake this morning and on the ball. Thank you, George. That's why he saved us from near death with fire the other week.
He's always on his phone.
Okay, last problem on the front page. Solid A is similar to solid B. So this is just like number 4, right? Only it's volume. If the volume of solid A is 21 inches cubed and the volume of solid B is 4536 inches cubed, how many times smaller is solid A than solid B? So what are we going to do? Thoughts on that? Look at what we did with number 4. What did we do? Okay, so because it's volume, haven't they given us A cubed over B cubed, right? And so solid A is 21 and solid B is 4536. If I want to know how many times smaller A is than B, what do I want to do with that? What's the first thing I want to do? Don't I want to simplify that fraction?
Yeah.
So let's start there. Plug into your calculator, use your fraction button. 21 fraction 4536. Oh, my calculator won't do that. So what numbers divide into 21? So if your calculator display is so small that you can't get all of this in there, which I can't, I can only get to the 453. What are the only, go to the smaller number, what are the only two numbers that divide into 21? 7 and 3. Question? Well, no, it still won't because my calculator display isn't that big.
I know the one
It still won't. Because if I put it in backwards, 45, 36, fraction, 21. Oh gosh, it did. Why is that? That's weird. Oh, neither here nor there. I don't like doing that backwards. 40. Why won't it put that one in there? That's weird. That's an interesting thought. Apparently you can't have big denominators. Well, neither here nor there. I'm going to go ahead and use my still thought. How do I test for threes, for division by 3? What do you do? Come on, think. What do you do? What's the rules for threes? Divisibility rule for threes. Seriously? Nobody knows the divisibility rule for 3 in here. Allie? Perfect. So we're going to add up the numbers. What's 4 plus 5? 9. 9 plus 3? 12 plus 6? Isn't 18 divisible by 3? So we're going to start there. And it's possible that 7 goes in there too. But I'm just going to start with 3. So 3 goes into 21 7 times. And 3 goes into 45, 36. 1, 5, 1, 2. Now I'm going to reduce that. So 7. Oh, see, my calculator, apparently you're right, Danya. Will only give me 3 digits. So I bet you 7 goes in there.
It does. 260.
Yep. Well, that's super annoying. So apparently you're only allowed to have a 3-digit denominator. Okay, so that's a cubed, b cubed reduced. How do we find what the scale factor is?
You take the.
This is cubed,
Yeah, the cube root.
so cube root. So what's the cube root of 1? 1. What's the cube root of 216? So it says how many times smaller is solid A than solid B? Isn't it 6 times smaller? You don't want to say it's 1/6 smaller. Wouldn't you take, where's my volume? So wouldn't you take this volume right here of solid B and divide it by 6 to get solid A? So solid A is 6 times smaller than solid B. And because that's how they're asking it. So therefore, rephrase the question as an answer. Solid A is 6 times smaller. It's mostly because our scale factor is 1/6, so that's why it's 6 times smaller than solid B. So any questions on the front? All right, now we're going to explore what happens if we just change one dimension, not all of them. So changing only one dimension means that the figures are not similar. So in capital letters. Oh, that's terrible. I know, right? Thanks. So not similar. Girls? Therefore, we need another strategy. In this situation, you're going to choose test values. And we're going to choose easy test values. Calculate both the old and the new surface area and volume. Then you're going to compare your answers. So you have to do a little testing. And that means you have to know your surface area and volume formulas. Are you ready? So example 9. How many times larger is the volume of a cylinder if just the height is doubled? Well, we don't know anything about the cylinder. We just know we're going to double the height. So what is the volume formula for a cylinder? What's the volume formula for a cylinder? Very good. So area of the base, which is pi r squared, times the height. Well, BH, but I need to know what B is. So we're replacing the B, which is this part right here, with its actual formula. So that means I need to know radius and height. So choose easy values for the radius and height. What are easy values for radius and height?
2 and 3.
Easier than 2.
1.
1, right? So we're going to let R equal 1 and H equal 1. So this is our step 1. So then step 2, we're going to find the old volume. So volume old is going to equal pi times 1 squared times 1 for the height. So what does that give us? What's 1 squared
4.
times 1
4.
times pi? Isn't it just 1 pi? That's why we want to choose values of 1. Sometimes we can't always choose 1, and it just depends upon what our scale factor is. If our scale factor is a fraction, we're going to get a little smarter, but for right now, we're just going to use 1. So then, step 3, you're going to calculate the new volume. So new is still pi times, but this time, we're just going to double the height. So if we double the height, so the new height is going to be what? What's 1 times 2? 2. So then we're still going to use our old radius. That hasn't changed. But our new height is going to be 2 this time. So what is 1 squared? 1 times 2 times pi. 2 pi. So then you're going to compare old to new. So step 4, how many times larger is the volume of, if it's doubled? So for number 4, we're going to take volume of the new and put it over volume of the old. So volume of the new is 2 pi, and volume of the old is pi, isn't it? Don't the pi's cancel? Isn't it equal to 2 to 1? So therefore, the volume is 2 times larger. So just set up your ratios. Does that make sense? We're just guessing and checking. We're coming up with values ourselves. So look at number 10. How many times larger is the volume of a square pyramid if the base edge is tripled? So our square pyramid would look something like this. Right? And they're saying that this edge right here, because if this is a square, those are both the same. They're saying that edge there is going to be tripled. So how many times larger is the volume of a square pyramid? Well, what is the formula for volume of a square pyramid? It's pointy. So volume is always big B times H, right? But this one's pointy, so isn't it 1/3? What's big B? Side squared, right, times the height, right? So 1/3 big B times height. So side squared is our big B. So we have to come up with values. So step 1, you're going to determine values for S and H. So what are we going to let S be? 1. And H? Also 1. Make it easy on yourself. You can choose anything you want to, but those are easier. So then let's find the old volume. So step 2, the old volume is equal to S, which is 1 squared, times H, which is 1, all divided by 3. So what's 1 squared? times 1 divided by 3. Doesn't come out to be 1/3 units cubed, whatever it might be. So then we're going to find the volume of the new one. So if our base edge is tripled, doesn't that mean that I'm going to take S and multiply it by 3? So let's go ahead and plug in. So my S this time is 3, and we're going to square that, times my height has not changed, it's still 1, and then all of that's divided by 3. So then what's 3 squared? 3 squared, 9 times 1, 9 divided by 3, 3. So old volume is 1/3, new volume is 3. So then step 4, let's compare the two. So new volume versus old. New volume is 3. Old is 1/3. Let's review fraction rules. When you have a fraction of fraction, haven't we talked about ketchup, mustard, relish in this class? No? What are things you put on your hot dog? Ketchup, mustard, relish.
Oh.
Think of the baseball game. The race between ketchup, mustard, and relish, right? So that's what you're all putting on your hot dog. You're putting ketchup, mustard, and relish on your hot dog, whether you like it or not. Okay? So here's the deal. Oh, wow, we're talking about hot dogs. I'm so hungry. So ketchup means keep. So you're going to keep the first fraction, or the numerator stays the same. I'm going to go ahead and put it over 1. So we're keeping the numerator. Mustard means we're changing division into multiplication. And then relish means reciprocal. So keep, multiply, reciprocal. Ketchup, mustard, relish. So we're going to take the reciprocal of 1/3, which isn't that 3 over 1. So what does that equal? 9 to 1, right? It's 9 to 1. 3 times 3 is 9 to 1, right?
Okay.
So isn't the new volume 9 times as big? And if you take this volume and multiply it by 9, what's 9 times 1/3? 3. So it works. So therefore, the volume, what was that, is 9 times larger. That's a 9. Okay? We're almost there. Number 11. How many times smaller is the surface area of a sphere if the radius is multiplied by 1/2? Well, what's the formula for surface area of a sphere? You're supposed to know that. Surface area of a sphere. Surface area and volume, they always have pi r in them, right?
Yes.
But because it's surface area, it's pi r what?
Oh, wait.
Squared. And so what's the coefficient?
4.
Can you see that far? Really? Oh, wow. Okay, so we've got 4/3 pi r squared. Do you all agree with that? Or are you just accepting George's visual abilities? Is that the surface area?
Right.
Nope, you're not right.
Is that up for the
No, go back and look over there. So George needs to have better eyeballs. What's the surface area of a sphere?
That's probably 4.
All right, good. Oh, wait. So, make sure that you know your formulas. If you use them wrong, right? So it's 4 pi r squared. 4/3 pi r cubed is your volume. So the only unknown we have here is r, agreed? But this time, the radius is being multiplied by 1/2. If I let r be 1 and I multiply it by a half, then doesn't that become a half? Let's choose something, if your scale factor is a fraction, let's choose something that's divisible by that denominator.
2.
I agree. So so step 1, we're going to let r equal 2. Anything that's divisible by 2. So typically I'll go with the smallest value possible. So then we're going to proceed as we have been. We're going to find the old surface area. So surface area, old, is equal to 4 pi times 2 squared. What is 2 squared? 4 times 4.
16.
So we've got 16 pi. Don't multiply pi through, just leave it 16 pi. And then we're going to find the new surface area. So let's find our new radius. So if radius is 2 and we're multiplying it by a half, what's 2 times a half? 1. So won't our new radius equal 1? So we're going to put 1 here. So what is 1 squared times 4? So we get 4 pi. So then we're going to compare. So step 4, we've got the surface area of our new over the surface area of our old. Well, our new is 4 pi. Our old is 16 pi. Don't the pi's cancel? What does 4/16 reduce to? 1/4. So isn't the surface area of the new 4 times smaller? It's 1/4 as big, but it's 4 times smaller. So make sure you focus on how they ask that. Therefore, the surface area is 4 times smaller. Because it's 1/4, it's smaller, not larger. Notice that I always do new over old. So then I want you to look at number 12, but before we do 12, let's determine the formula for surface area of a cube. What's the surface area of any prism? Yeah, pH plus 2 big B. So you have this cube. Look, Dustin, did you see how nice that cube is?
It's actually a good cube.
Right? So we've got X, X, and X. Aren't all the dimensions going to be the same on a cube? So if your side length is going to be multiplied by 1/4, what do you think you're going to let X be? Why do you say 4, George? Yeah, 4 is divisible by 4, 1/4. So that's where I would start. So go ahead. Work on it. Talk to your table group. How are you going to find the perimeter? Because now this is 4 and 4, right? So find the perimeter of the base. I'll quietly work up here. So let's look at what happened. So if you're finding, if this is P for the old surface area, aren't all of these 4 going all the way around? So what's 4 times 4 for the perimeter? So that's where the 16 came from. And then H is the height, so the height here is 4, plus 2 times big B. Well, big B is a square, surface area, or the area of a square is side times side, so I just did 4 times 4. That's where the second 16 comes from. Then we took 4 and divided it by 4, because we multiplied it by 1/4 to get the new dimension, which is now going to be 1. So I did the same thing again. 1 times 4, that's your perimeter, is 4. The height is now 1, so H is 1. Your big B is side times side, so 1 times 1 is 1. The area of that base is 1. And so I get 96 for the old, 6 for the new. What do I do with that? Yep, so I'm going to take the surface area of the new divided by surface area of the old. My new is 6, my old is 96. So reduce those, what do you get? 1 to 16. And so the question is saying, how many times smaller? So how many times smaller? 16. So therefore, the cube, or the cube surface area, will be 16 times smaller. Last one. How many times larger is the volume of a cone if the radius is multiplied by 6? So this time it's not a fraction, so what can we use for our radius? What are you going to let your radius be? 1. So, but the important thing is, what is the volume of a cone? Cones are pointy. 1/3 big B times H. So what's big B on a cone? Pi r squared H. So I've got 2 unknowns. So for step 1, I'm going to let R equal 1 and H equal 1. Let them both equal 1. Let's find the old volume. So step 2, volume old, just run it through. Pi times 1 squared times height of 1, all divided by 3. So what do we get this time? Pi over 3. Then your new volume, so we've got pi, but this time we've got to figure out our new dimension. So we're going to multiply the radius by 6. So the new radius is going to be 6. That's new for n. It's a weird looking n, but there we go. So we've got pi times that 6 squared, but the height hasn't changed. It's still 1. All divided by 3. So what is 6 squared? 36 times 1? 36. What's 36 divided by 3? 12. So we get 12 pi. So all that's left is to compare. So last step, we're going to compare the volume of the new, always new to old, to the volume of the old. So our new is 12 pi, and our old is pi over 3. So again, reviewing those fraction rules, we're going to ketchup, mustard, relish. So we're going to keep. So the 12 pi, we're going to keep. I'm going to put that over 1. Instead of dividing, we're going to mustard or multiply. And then we're going to relish, which is reciprocal. The reciprocal of 3 over pi, or pi over 3 is 3 over pi. That means the pi's cancel, which they should, but the 3 doesn't. So you've got 3 times 12, which is 36. So therefore, the new volume is 36 times larger. So therefore, the new volume is 36 times larger. Any questions? So you get a lot of notes to follow for your homework. Every homework piece, for the most part, should follow something that's on these notes.